Alright guys, so this last lesson we learned about the difference between a function and a relation. So a function, as a friendly reminder, okay, something is a function, or a set is a function if each input has one output. Alright, so today we're going to be talking about function notation. And this stuff I think you guys are really going to catch on to pretty well. So just hear me out on this. This is read as f of x, g of x, which you should have already learned about last year, h of x. These are all other ways to write functions and relationships between numbers. Some examples. You guys are used to this one. We just talked about it in chapter 2. We have y is equal to 2x minus 3. That's slope-intercept form. That is the same as f of x is equal to 2x minus 3. Here, y is equal to 1/2 x plus 1. It's the same thing as f of x is equal to 1/2 x plus 1. When y is equal to negative 3x, that's the same thing as g of x is equal to negative 3x. Y is a function of, is another way we could say that, and f is a function of g of x. So f of x is a function of 2x minus 3. These are some other vocab terms that we can start getting used to saying. So, utilizing function notation is another way to say substitute in a value for expression 4. Okay? Basically, they're going to give us a rule or something we have to do. So, here it says, examples, determine the value of f of 2 for each function. Guys, all we have to do is plug in 2 for x. So, if f is 2, if f of 2 is 2, what we're going to do is we're going to go in and say, well, okay, I know for this one that I just need to plug in 2. So negative 9 times 2 minus 1. Well, negative 9 times 2 is negative 18. Negative 18 minus 1, negative 19. Let's try this next one. 2 times 2, right, plus 29. Well, that's going to give me 33. 2 times 1/2 minus 3. 2 times 1/2 is 1. 1 minus 3 is negative 2. Alright, let's try this. So determine the values for each using the function. This stuff is fun. It says g of x is equal to negative 4x minus 1. So I'm going to go ahead and plug in 3 for this. So put 3 in for x. So negative 4 times 3 minus 1, well that's negative 13. What about this one? When g is negative 4, well negative 4 times negative 4 minus 1, that's 16 minus 1, 15. What about 0? Well, negative 4 times 0 minus 1, negative 1. This one's kind of tricky, okay? This is saying that we have to plug negative 1 in, but then multiply our answer by 5. So let's do that. We get negative 4 times negative 1 minus 1, negative 4 times negative 1. Well, that's going to give me 4. 4 minus 1 is 3. 3 times 5, well, 15. Go ahead and try this one. They want you, I'm going to have you do this on your own, they want you to do g of 3, whatever your answer is, they want you to add g of negative 10 to that. We will go over that tomorrow in class. Go ahead and try number 5. Alright, let's go on to the next page after you've paused that and solved that problem I asked you to do. This just basically says graph from function notation examples. Guys, this is slope-intercept form. So we know my y-intercept is negative 1. Alright, my slope is negative 4 or negative 4 over 1. So I'm going down 4, 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. Okay, from here I can't go down anymore, so I'm going to go up 1, 2, 3, 4 to the left one, up 1, 2, 3, 4 to the left one. And here is my line. Alright, let's do this next one. Got to distribute first. When you do that, let's see, you should get 0.5 times 2x is going to give you 1x. Okay, and 0.5 times negative 5 will give you negative 2.5. So g of x, okay, is equal to 1x minus 2.5. So let's figure out our b, negative 2.5. And we are going, this is a positive 1x. Up 1 over 1, 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 so on and so forth. Down 1 to the left one, down 1 to the left one, down 1 to the left one. Graph should look something like that. I'm going to have you do number H. My hint to you is to figure out what your B is and what your slope is, and then go from there. All right, so go ahead and pause, do number 3. And I'm going to flip this over to the word problems. So here it says Cassie runs a babysitting business. All right, it says she charges a one-time insurance fee plus the cost per hour. Below is a table of what she currently has earned. They want us to figure out what is the linear equation that can represent Cassie's data. So we need to find her slope, which is her charge per hour. We need to figure out what her insurance charge is, and then how much she would make after 15 hours. So let's find our slope. We know my slope is equal to y2 minus y1 over x2 minus x1. We can plug in any 2 points. For me, I'm going to use this one and this one, the first 2. So y sub 2 will be 66 minus 46. Y sub 1 is 5 minus 3. You get 20 over 2, which is 10. So my slope is 10. What is her charge per hour? 10. All right, write a linear equation that represents Cassie's data. We can't do that yet. What is her insurance charge? You can do slope-intercept or point slope for this. I'm going to do point slope. We know y minus y1 is equal to mx minus x1. All right, I'm going to plug in the points 46 and 3 as my first x and y. Okay, so y minus 46 equals my slope of 10 times x minus 3. Okay, we have y minus 46 is equal to 10x minus 30. Add 46 to both sides. We have y equals 10x plus 16. What does this mean? Here's our slope. So that must mean her insurance fee is $16. Okay, a one-time insurance fee. All right, well now we should be able to write that linear equation, right? Y is equal to my slope, 10x, plus Cassie's insurance fee. Okay, I want you to go ahead and figure out how much she would make after 15 hours. Put that number right here. So you're plugging 15 in for x. Okay, I'm going to have you try this next one on your own too. Brett has decided to rent 4-wheelers each weekend. He is charged a rental charge plus a cost per mile. So this cost per mile is going to be his slope. The rental charge is that one-time fee, or your B. Okay, so below is the table of what he's paid for the last 5 weekends. Go ahead, solve this one. We're going to go over these tomorrow in class.